Good morning, or afternoon, or whatever it is where you are when this plays. My name is Charity Majors. I am co-founder and CTO of Honeycomb.io. I am the co-author of Database Reliability Engineering and Observability Engineering, and I work at Honeycomb. So one of the most cliched phrases in tech is that every company is now a technology company. And one of the implications of this is that questions of engineering efficiency and how will we execute are no longer niche concerns, which means that it really pays to be on a high-performing team. The way I define this is that high-performing teams are the ones that get to spend most of their time working on interesting, novel problems that move the business materially forward. These numbers were taken from the DORA report. They're probably no surprise to anyone, but every time I look at them, I am surprised all over again at just how big of a gulf there is between teams that are really executing and teams that aren't. Teams matter because the team is the smallest viable unit of software ownership. Individuals don't own software. An individual who owns a service is a single point of failure. Teams collectively own and understand and develop software. And how do we build high-performing teams? Obviously, by hiring all the ex-Googlers and ex-Facebook. No, of course not. Of course not. To start with, how well does your team perform is not the same as saying, how good are you at engineering? Because your ability to ship code swiftly, consistently, safely has less to do with what's up here in your head and much more to do with the socio-technical system that you participate in. You can be the best engineer in the world. You can be Kent Beck. You join a team that takes 2 months to ship a single line of code, and it's going to take you 2 months to ship a single line of code. Which is why I think that if technical leaders have one job, it's this. It's paying attention to the feedback loops at the heart of our systems. When I think about the practices that I would consider to be modern software development practices, like owning your code in production, instrumenting your code as you go, practicing observability-driven development, testing in production, separating deploys from releases, using feature flags, continuous deployment. Each of these amplifies and reinforces the others. And together and individually, they're all about fast feedback loops. Getting your code into production as fast as you possibly can after you write it. Because when it comes to software, speed is safety. So getting code to production fast is the core feedback loop, the key feedback loop that sits at the heart of really everything else. And the reason for that is, it's one of my favorite graphs of all time, is that the cost of finding and fixing bugs goes up exponentially from the moment that you write them. You type a bug, you backspace, good for you. It's the fastest you can possibly find it and fixed it. Your next opportunity is when you run your tests. And after that, your next best chance of finding it is right after you ship your code. If you close that feedback loop by going and looking at it through the lens of the instrumentation you just wrote and asking yourself, is it doing what I expect it to do? Does anything else look weird? Your ability to do this, though, to move really swiftly with confidence, is grounded in the quality of your observability. What does that even mean these days? If any of you know who I am, it's probably because of observability. Back in 2016, the term was not in use in the industry when my co-founder Christine and I set out to borrow it from control systems theory and define it as it applied to software. And we spent years trying to figure out how to implement, like in control systems theory, observability is the mathematical dual of controllability, and it refers to how well can you understand the internal system state just by observing it from the outside. And so we came up with this laundry list of things: cardinality, dimensionality, blah, 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 blah. A couple of years later, the definition came along from Peter Borgen. It said observability has 3 pillars. A few years after that, Gartner added it to the quadrant. These days, this is how I think about it. I think of observability as a property of complex systems, just like reliability, just like performance. I like this because it puts the emphasis on the system itself, not the tooling. But if observability is, a property of complex systems, we've kind of erased over the differences that sent us looking for a new term in the first place, which is the enormous sort of gulf in cost, usability, that exists between generations of tooling. And in the parlance of semantic versioning, major version changes are called for when you have breaking changes, backwards incompatible changes. And I think that's what we have here. Observability 1.0 is your 3 pillars definition. You've got metrics, logs, and traces. Actually, those are 3 different data types, but you've probably got more than that, right? You've probably got your APM tool and your run tool and your tracing tool and your structured logs and your unstructured logs and your metrics and your dashboards and your profiling tools and your analytics tools, right? You're probably paying for every single request that enters your system. You're paying to store it again and again and again and again and again in a bunch of locally optimized formats. With 2.0, you have a single source of truth. You have arbitrarily wide structured data blobs with unique request IDs, with trace IDs, with span IDs. So these are not compatible. You have one source of truth or you have many. You have 3 pillars or you have one. I'm going to run past these overview slides pretty quickly because we're going to spend a couple minutes going down into each one of them. But basically, 1.0, that's your overview. 2.0, that's your overview. When we started talking about observability, we were trying to position it versus monitoring, right? Monitoring is, is treating systems like black boxes. And so we spent a lot of time talking about how you only have observability if you have all these things. Nobody could remember what all these things were, which is why I think it's much simpler and easier to remember. If you have 3 pillars, many tools, you're in observability 1.0 land. If you have a single source of truth from which you can derive all the other data types, then you have observability 2.0. So let's talk about how the data gets stored first. We've talked about how you have a different tool for every format, for every local use case. But another thing that's important to keep in mind here is that in 2.0, you're storing these raw events, which means that you're making the decisions about how to query them at read time. One of the reasons observability 1.0 is so expensive is because you're doing all of your aggregation at write time. You're making the decision about which metrics to collect, which questions you're going to be able to ask days, weeks, months, years before you're actually using them. Now, under the hood, of course, there's really only 3 types of data. There's the metric, there's strings, and then there's structured logs. And historically, RUM tools have built on top of metrics to understand your browser, your user sessions. APM tools have been built on top of metrics to help you understand application performance. Right now, the overwhelming amount of tooling in the space is built on top of metrics as their fundamental building block. And for historical reasons, this is easy to understand because historically, hardware was expensive and the metric is tiny, fast, and cheap. There are 2 ways you can use the term metric. One is sort of a generic synonym for telemetry, and then there's the capital M metric. A metric is a single number with some tags appended, stored in time series databases. These are the great granddaddy of telemetry formats. They are undoubtedly very fast and cheap. However, you store no context in time series database, no connective tissue, no relational information, no data structures, no cardinality, which means your ability, you can't zoom in, you can't zoom out, you can't do anything except the metrics that you define in advance. Now, I have a reputation for hating metrics, which is not true. Metrics are the great tool for many jobs. Metrics are the right tool for summarizing vast quantities of data. They're also a great tool for doing summaries that age out over time. This is famously what RRD tool did, right? You'd capture your metrics in these very fine-grained ways, and then as the data got older, you would age out the detail but retain the shape. So it was very cost effective. Your cost would not rise even as your data volume rised. At a certain amount of very high scale, metrics are the only tool for the job, although people tend to overestimate how high that scale is. They're the right tool. They're the right tool for the jobs of summarizing a lot of data, but they're not the right tool for introspecting and understanding your software. To understand our systems, we need cardinality and we need relational data, which is why we turn to logs. Even unstructured logs are more powerful than metrics because they preserve some amount of context and connective tissue. However, with unstructured logs, the more data you get, the slower it gets to search it, because the only thing you can do is string search, which is why it's the year 2024. Everybody should be structuring their data. Who uses it and how? This is one of the most interesting sort of socio-technical implications of the 1.0 to 2.0 switch. Observability, monitoring telemetry in the olden days has always been about how you operate your code. It's been concerned with MTTR, MTTD, crashes, bugs, downtime, SLOs. So much of it is about there's a problem. How do I understand that? Very much an ops concern. Observability 2.0, yes, it includes bugs, it includes crashes, it includes all those things, but it's bigger than that. Where 1.0 is about how you operate your code, 2.0 is about how you develop your code. It's the foundation for hooking up these really fast, efficient feedback loops that let you get your code into production quickly. And it's like putting on your glasses, if you're blind like me, before you go zooming down the highway. The goal is to be able to drive so fast that it doesn't even feel like you're course correcting, right? You're just driving, or you're just building. OLI 1.0 is about how you operate your code. OLI 2.0 is about how you develop your code. Then there's how you interact with production. In 1.0 land, you typically would deploy your code and wait to get paged. In fact, it's kind of a point of pride that you shouldn't have to spend all day looking at your system, because we were reacting to, of course, the days of the NOCs, right? Network operations centers, where poor SAPs would sit there just surrounded by dashboards, just staring at dashboards all day. That was bad. So we're like, great. In high-performing teams, you don't need to look at your system all day. Your system will let you know when you need to go look at it. But nowadays, I feel like, part of the agreement here is we put developers on call for their code. We expect engineers, your job doesn't end when your test pass. Your job ends when it's working in production. And so in order to do that, we have raised the bar for alerting people. You don't wake people up unless users are actually in pain. And so the bar for waking people up is high, as it should be, which means that most bugs never reach that bar, right? Most problems, most behavioral things. So you need to look at it, right? You need to interact with your code, not just when it's broken. You also need to know what good looks like. So you're in constant conversation with your code in production. How you debug, because there's no connective tissue or very little predefined connective tissue in the 1.0 world, you end up filling in the gaps by guessing and using intuition, which means that the best debuggers are always the people who have been there the longest. But this is not an inevitable fact of software. And in fact, in an Observability 2.0 world, because the connective tissue exists, the best debuggers are the people who are the most curious. The cost model, again, I've written a lot about this, so I'm going to gloss over it pretty quickly. But in the 1.0 world, you pay to store your data again and again and again and again. For every single request that enters your system, you might pay to store it in 7 or 10 times. And in 2.0, you pay to store it once. Now, I'm never going to claim that good observability is cheap. It's not. It will usually be the second highest bill after your cloud bill. 10 to 15% of your cloud bill or your infrastructure bill for observability is normal, but your costs should be predictable and they should go up. As they go up, you should get more value out of them. The reason 1.0 is so expensive is because of the cost multiplier and because of the cardinality thing. I wrote a whole white paper about this. You can download it on the Honeycomb site. But basically, if you want to capture just request.latency for 1,000 hosts, 5 methods, 20 handlers, 63 status code, it costs you $63,000 a month. It's absurd. Now, of course, anyone who is great at metrics was going to start bridling at this and going, but that's not how we do this. Obviously, we don't capture 63 status codes. We bucket them into 1xx, 2xx. Yeah, I know. But I would argue that it's actually really meaningful whether a request was a 502 or a 504. I don't know how many times I've debugged something just because it had a wacky status code or a weird browser string or something like that. Cardinality is power, dude. So with Observability 1.0 tools, they're expensive, but that's not the worst part. The worst part is that as you pay more, the value that you get out goes down. Observability 2.0 is faster, cheaper, simpler to use. The way you're doing it now is the hard way. We've learned to be incredibly clever when it comes to bringing out every bit of utility we can from metrics and unstructured logs. But what if we didn't have to work that hard? What if it was all just data? Something I hear a lot from people is that, oh my God, 2.0 sounds great, but we haven't mastered 1.0 yet, which is exactly the wrong way to be thinking about it, because 1.0 is so much harder than 2.0. Trying to train engineers to be able to figure out which data type to capture their telemetry in, to figure out what kind of cardinality it's going to have when it hits production, and then it changes out from underneath you, trying to figure out which of your tools do, it's absurd. It's insane. Metrics are a bridge to our past, and structured logs are a bridge to the future. I'm not saying that metrics are useless. They still have a place, but where most of our tools are built on metrics, like typically 80% of our tools are built on metrics and 20% of the telemetry is in logs, that ratio needs to be inverted. Most of our tools need to use structured logs. With structured logs, we should be able to capture all of these dimensions and hundreds more, thousands more, and just slice and dice, break down, group by, zoom in, zoom out, derive your SLOs, derive your metrics, derive your dashboards, instead of making those decisions at the time that you're gathering the data. We build better systems when we build software this way. We become better engineers when we build software this way. So this doesn't need to be a, forklift, a big leap all at once. That's hard. I've often said that I think if you're asking people to adopt a new mental model or to change developer tools, what you're offering them needs to be an order of magnitude cheaper or an order of magnitude better. Not 20% better, not 50% better, like a really significant amount better. What you can start doing now to start moving towards Observability 2.0. First, start by instrumenting your code using the principles of canonical logs. It's impossible to overstate the value of doing this. Make your logs wide. Emit fewer logs, instead of emitting, many log lines per request, you should be emitting one per request, per hop, or per span, but make them wider. With Honeycomb, we charge on the number of events. You can make them infinitely wide. The wider they are, the better. The more context you have, the richer they are, the more ability you have to do correlations and detect outliers. Rich, wide, wide. Add trace IDs and span IDs so that you can start visualizing your logs over time using the same events instead of having to hop between tools. The problem with 1.0 is you've got the engineer sitting here in the middle of all these tools, and the engineer is the one that connects them. So you're doing a lot of visualizing. This metric is shaped like that, so it's probably the same one that has a similar shape. You don't know that for sure. You're just guessing. And the more complex your system, the less reliable those guesses are. Or you're like, you find it in your logs and you copy paste, an ID from your log to the tool, to your tracing tool, and you hope that you sample it in. It's absurd, right? You should be able to visualize the same events instead of having them captured completely separately. Feed your data, feed these wide logs into a columnar store. to move away from a system where you have to like have predefined indexes or schemas. Use a storage engine that supports high cardinality. Pipe all this stuff into ClickHouse. It's a great intermediate step. And look for tools with explorable interfaces. I also have a reputation for hating dashboards. I don't hate dashboards. Dynamic dashboards are great. Dashboards that let you zoom in, zoom out, that let you ask questions and interact with them are terrific. Static dashboards that you just have to like flip through and like scan with your eyeballs are not. Got us here, won't get us there. On the top, that was a diagram of a lamp stack. In the middle, that was an infrastructure diagram of Parse, circa 2013. And that one on the bottom is actually a visualization of the US electrical grid. And that's the kind of system that we should be building for in our minds. Something that's dynamic and far-flung and chaotic, where, a tree is going to fall over on Main Street in the middle of Ohio tomorrow. You can't predict which street or which town. You shouldn't try. You should have the instrumentation that you can quickly and swiftly identify where something is happening. Because the dirty little secret is our systems are becoming too complex for us to brute force our way through, or to just, the stuff that can be done in autopilot is going to be automated out of existence. Writing code is not the hard part. It has never been the hard part. The hard part of software is understanding it, maintaining it, extending it, scaling it, operating it, refactoring it, reasoning about it over generations of engineers. We can't try and hold a model of these systems in our head and reason about them or connect between tools by guessing. The teams that try will lose. Our systems are increasingly emergent and unpredictable. Canned playbooks won't work. It takes our full emotional engagement and creative selves. Observability 2.0 is here to advance the craft of software engineering. It's here by front-loading observability. We are here to make it faster and safer to bring change into the world, to make change less traumatic, less difficult. Ultimately, we're trying to make this a more humane profession. The biggest obstacle between us and a better world has always been we don't believe one is possible. We don't believe we're good enough. We don't believe it's for us. But increasingly, we live in a world where there aren't devs over here and ops over there. Every engineer writes code. Every engineer owns their code in production. And everybody deserves the tools to do it well. So in conclusion, we'll end with my favorite picture of all time. Are we too busy to improve? Yes? No? Hopefully not. Thank you.